Scene script. Have you ever wondered how big companies manage their applications efficiently? The answer is Kubernetes. Kubernetes, often symbolized as a ship's wheel, is an open-source platform that has revolutionized the IT industry. It was born in the labs of Google, designed to automate the process of deploying, scaling, and operating application containers. Imagine having a personal assistant who takes care of all your tasks, making your life simpler and more productive. That's Kubernetes for the world of software. It's like a conductor ensuring that all parts of the orchestra, or in this case applications, are working in harmony. It's the backbone behind the smooth functioning of numerous businesses, big and small, across the globe. In essence, Kubernetes is a platform that manages containerized applications across multiple hosts. It provides the infrastructure to build a truly container-centric development environment. Now you might be wondering, why should we use Kubernetes? Let's dive in. Why is Kubernetes the go-to for many IT professionals? That's an excellent question. As we delve into the world of Kubernetes, there are a few key attributes that make it an attractive tool for IT professionals worldwide. Firstly, Kubernetes is renowned for its ability to handle a substantial load of work. It's like a highly efficient manager overseeing a bustling city of applications, ensuring every task is done on time and to perfection. With Kubernetes, you can run thousands of containers, each performing different tasks all at the same time. It's the equivalent of juggling 100 balls without dropping a single one. Secondly, Kubernetes is highly scalable. Imagine you've just launched a new app and it's an overnight sensation. Suddenly, you have millions of users logging in, and your server load is through the roof. Without a system like Kubernetes, your servers could crash under the pressure. But Kubernetes is built to handle such situations. It can scale up your resources to match the demand, ensuring your app runs smoothly, no matter how many people are using it. Next, we cannot overlook Kubernetes' ability to manage services. It doesn't just deploy your applications, it takes care of them throughout their lifecycle. Kubernetes ensures that your applications are always running as they should be, and if a problem arises, it automatically restarts or replaces the containers as needed. It's like having a dedicated IT team working around the clock, keeping everything in check. Moreover, Kubernetes provides updates with zero downtime deployments. In the digital age, downtime equals lost business. With Kubernetes, you can update your applications without affecting your users. It's like changing the tires on a moving car. Kubernetes rolls out updates one by one, ensuring that there's always a version of your app available to users while the update is taking place. Impressive, isn't it? But how does Kubernetes achieve all these? Stay tuned as we dive deeper into the architecture of Kubernetes in the next scene. The secret sauce of Kubernetes is its unique architecture, and what a compelling blend it is. To appreciate the genius of Kubernetes, let's delve into its structure, which is principally divided into two types of nodes: master nodes and worker nodes. Master nodes are like the brain of the operation. They make all the crucial decisions, control the state of the Kubernetes cluster, and coordinate all activities. There are four main components inside a master node. The first one is the API server, the communication hub of Kubernetes. It acts as the front-end interface, processing REST operations, validating them, and executing them. Next is etcd, the consistent and highly available key value store used as Kubernetes backing store for all cluster data. Think of it as the memory of the operation, storing all the cluster's information. Then we have the scheduler, a key decision maker that allocates workloads to worker nodes based on resource availability and other constraints. It's like the traffic controller, determining where and when the work gets done. Lastly, there's the controller manager, which regulates the state of the cluster and performs routine tasks to maintain the desired state. Moving on to worker nodes, these are the workhorses of Kubernetes. They run your applications and workloads. Each worker node houses two components: the kubelet and the kube proxy. The kubelet makes sure that containers are running in a pod. It takes a set of pod specs, verifies that the containers described in those pod specs are up and running. It's like the diligent supervisor, ensuring everyone is doing their job. Lastly, we have the kube proxy, which handles network communications inside or outside of your cluster. It ensures that the networking environment is predictable, accessible, and isolated. It's like the postman delivering all the necessary communications. So in a nutshell, this is how Kubernetes is structured. It's a complex but efficient system, where each component has its role, working together to create a robust, scalable, and flexible environment for managing containerized applications. Now that we understand the architecture, it's time to see how it all comes together. Imagine an orchestra with Kubernetes as the conductor, a fitting analogy for what we're about to dive into. Let's explore Kubernetes in action, shall we? Consider you're running an online store and Black Friday's around the corner. Anticipating a surge in traffic, you need to ensure your website can handle the increased load. This is where Kubernetes comes into play. It starts with deploying your application in the form of containers, each encapsulating a piece of your application. Think of these containers as musicians in our orchestra, each playing a different instrument, but together creating a harmonious symphony. Kubernetes, our conductor, ensures that these containers, our musicians, are working in harmony. Now, as your online store becomes more popular and traffic starts increasing, you need more resources to handle the load. Kubernetes has got your back. It automatically scales up the number of containers based on the demand, just like a conductor might call in more musicians to maintain the performance's quality. But what happens when the traffic slows down? You wouldn't want to pay for resources you're not using, right? Kubernetes gracefully scales down the number of containers when they are no longer needed. It's as if our conductor, seeing the concert nearing its end, gracefully bids adieu to some musicians, ensuring a seamless performance while managing resources efficiently. Beyond deploying and scaling, Kubernetes also manages service discovery. In our orchestra, imagine if the violinist needs to follow the rhythm of the drummer. They need to discover each other to play in sync. Similarly, in a microservices architecture, services need to discover and communicate with each other. Kubernetes provides service discovery and networking capabilities to enable this communication, ensuring that all parts of your application work together seamlessly. So we've seen Kubernetes deploy, scale, and manage service discovery, all while orchestrating our application performance like a symphony. It's this orchestration that helps applications to be resilient, scalable, and efficient. Kubernetes sure does a lot, but how can you start using it? Stay tuned as we delve into this in our next segment. Getting started with Kubernetes is easier than you think. Let's dive right in. The first thing you'll want to do is to choose a platform for running Kubernetes. There are a number of excellent options available, but today we'll focus on three of the most popular ones: Google Kubernetes Engine, or GKE, Amazon Elastic Kubernetes Service, or EKS, and Azure Kubernetes Service, or AKS. Google's GKE offers a managed environment for deploying, managing, and scaling your applications using Google infrastructure. Amazon's EKS is a similar service, but it runs on the Amazon Web Services platform. Azure AKS, on the other hand, is Microsoft's solution that simplifies the deployment, management, and scaling of containerized applications using Microsoft's Azure infrastructure. Choosing a platform depends on your specific needs and the cloud services you're already using. For instance, if you're heavily invested in the Google Cloud platform, GKE might be your best bet. Next, you'll want to create a cluster, which is a group of machines that Kubernetes considers as a single unit. In Kubernetes, a cluster consists of at least one cluster master and multiple worker machines called nodes. These master and nodes communicate with each other via the Kubernetes API, which the master exposes. Once your cluster is set up, it's time to deploy an application. With Kubernetes, you can scale the number of replicas of your application to meet demand, roll out updates or rollbacks, and provide services that abstract away the complexity of the underlying network. To deploy an application, you'll need to create a Kubernetes deployment configuration. This configuration specifies the container image for your application, the number of replicas that you want to run, and a variety of other options. Once you've created your deployment, you can use the Kubernetes command line interface, or kubectl, to create the deployment on your cluster. And there you have it, your first step into the world of Kubernetes. Let's summarize what we've learned today. We began our journey with an introduction to Kubernetes, a powerful system designed for managing containerized applications across multiple hosts. We delved into why Kubernetes is crucial in today's tech landscape, highlighting its ability to orchestrate computing, networking, and storage infrastructure on behalf of user workloads. We then explored the architecture of Kubernetes, focusing on its master-slave configuration and the role of key components. We saw Kubernetes in action, demonstrating how it automates the deployment, scaling, and management of applications. Finally, we walked through the basics of getting started with Kubernetes, providing a practical guide to help you take your first steps. With Kubernetes, managing your applications becomes a breeze. This is just the tip of the iceberg. There's so much more to explore in